Good morning, everybody. Welcome to the respiratory system. Let me get to, there we go. So, dang it. So when we talk about the respiratory system, we're talking about our ability to take in oxygen so that our body can do all of its metabolic processes. And so this figure at the beginning of your text talks about how as we increase in elevation, it causes a strain on the respiratory system. That's because of differences in pressure. So we're going to talk about that later on, but I'll give you kind of that excitement, hopefully, so that you are wondering, what does pressure have to do with the respiratory system? So what is really the major function of the respiratory system? Well, the body needs energy. We need ATP. And so every metabolic reaction occurs associated with some ATP. ATP synthesis requires oxygen and it produces carbon dioxide. So that is cellular respiration. I'm sure you've all remember that from your high school biology class or your general biology class here at Spoon or in another school. And the way that we take oxygen, or that we get oxygen so that we can produce ATP, is by breathing. So we take in oxygen, and then we get rid of the waste product, carbon dioxide, which is the bad stuff that we don't want in our body. Well, we need some, but it's a waste, okay? So I told you that what is the major function? The major function then is to provide oxygen to our cells so that our cells can produce energy, or ATP. And it also gets rid of waste products like carbon dioxide, so we don't have too much carbon dioxide in our lung or in our blood. Carbon dioxide actually lowers our pH, and you don't want your pH to be lower than 7.35 to 7.45. So 7.35, you wouldn't want it to be lower than that. But the respiratory system has other functions as well. It serves to help us with speech. It helps us with our sense of smell. So the nasal cavity is part of our respiratory system. And it influences lymph and blood return. So remember, we have the skeletal muscle pump, but we also have the respiratory pump. And I mentioned the pH in the beginning. So what are the structures of the respiratory system? Respiratory system is rather small when you look at the structures. It starts with this nose, the nasal cavity. We move into the pharynx. Pharynx has three different parts. We have the nasopharynx, the oropharynx, and then we have the laryngopharynx right down here. It moves into this larynx here, and then we move into the trachea. From the trachea, we move into one of the two bronchi. These bronchi branch further and further in the lungs, and they end in the alveoli, right? So there's a conducting zone and a respiratory zone of the respiratory system. So the structures of the respiratory system can then be broken down into functional zones. So either the conducting zone, which is everything here, the nasal cavity, the pharynx, the larynx, and the trachea, moving into the bronchi. And then once we get inside the lungs, we have the respiratory bronchioles. Like I said, the bronchi branch further and further in the lungs, and eventually we get these tiny respiratory bronchioles, the alveolar ducts, and the alveoli. The alveoli are the tiny little sacs where gas exchange occurs. The respiratory system has a mucous membrane associated with it, so anything open to the external environment has to have a mucous membrane to protect it. And so we have different types of tissue associated with the respiratory system, but the majority of our respiratory system, specifically the conducting zone, is going to be pseudostratified columnar epithelium. But as we get closer and closer to the alveoli, the tissue gets smaller and smaller. So you start out with some pseudostratified columnar epithelium in the larynx and the trachea. And then as we move to the bronchi and get closer to the actual alveoli, we move to simple columnar epithelium. And then we'll move to, my goodness, simple cuboidal epithelium, and then eventually simple squamous epithelium in the alveoli. There are a few examples of areas that don't have the pseudostratified columnar or simple columnar epithelium, and I'll talk about them in just a second, okay? So I just mentioned that the epithelium becomes thinner and thinner as we move from the nasal cavity all the way to the alveoli. So we have pseudostratified first, then it goes to simple columnar, and then it goes to simple cuboidal, and then eventually simple squamous, which I just mentioned. But in the pharynx, in the oro and laryngopharynx, we actually have non-keratinized stratified squamous epithelium. There's a reason for that. The pharynx has two functions, so it's part of two different organ systems. We have it in the respiratory system for air or gas exchange, but we also have it in the digestive system for movement of food to the esophagus. And because of that, we have to have a thicker tissue. So everybody has likely eaten chips. And if you're eating a chip and you don't chew it just right, you don't chew it enough, and you swallow, that chip scrapes down your throat, because I'm pretty sure everybody has had that happen. That scraping down the throat, it hurts as it moves down because you're actually cutting into that tissue, right? So if we only had a single layer of epithelium, like your pseudostratified ciliated or your simple ciliated or your simple cuboidal, these are all single layers of tissue, you would start to bleed in the throat, and that would be bad. So we have stratified squamous epithelium that are available to allow us that will protect our oropharynx and laryngopharynx. And also the superior portion of the larynx is lined with non-keratinized stratified squamous epithelium as well. So let's look at the conducting zone first, and then we'll look at the respiratory zone. All right, so the conducting zone starts with that nasal cavity. And so we have two nostrils, the nostrils, one on each side of the nasal septum, where air can be pulled in, okay? The external region of the nasal, we have bone, the nasal bone, back close to the eyes, and then the protrusion of the nasal is actually cartilage. So if you break the cartilage, it's not going to be fixed as easily. If you break the bone, you can actually fix that much easier. And then you have stratified squamous epithelium keratinized surrounding that. Deep to the stratified squamous epithelium, we have dense regular connective tissue, okay? So air moves in through these nasal, through the nostrils of the nasal cavity. That's what I meant to say. And then the nasal cavity has these conch right here. These conch actually helps when air moves in, it causes the air to move around. So it doesn't just go in one direction and just go through. It moves around, which allows us to, which allows the air to hit the mucous membranes. So anything we inhale that has an odorant molecule, we'll be able to smell. Also, bacteria or any pathogens we're inhaling can get trapped in the mucosal region. The air is going to move back here to the choanine. The choanine is the back portion of the nasal cavity, and that's where we actually enter into the nasopharynx, okay? So the choanine is important because you need to be able to take air and move it all the way through into the nasopharynx and then down through the oropharynx, laryngopharynx, larynx, trachea, bronchi, all the way into the alveoli. Choanal atresia is a disorder in which you have a blockage at the back of the nasal cavity. So a unilateral choanal atresia, where you have a blockage on one side, will still allow you to get air in, but it's not as effective because you're not getting as much air in. A bilateral choanal atresia can be life-threatening in infants. So infants breathe through their nasal cavity. They don't breathe when they're first born. They don't breathe through their mouth. They start breathing through their mouth as they age. And because of that, they're going to have troubles if they have a blockage. So, if you actually click on this video, it'll go through and show you an infant's surgery. So they don't actually show the infant and everything. They show the surgery of what they're doing to break the, I believe there's a bone blockage that they then clean up so that the baby can breathe properly. And as you can see, there's some type of a, it looks almost like the bone is growing together there. That's causing the blockage. So moving into that nasal cavity is a nasolacrimal duct, which we've talked about it when we talked about bones. We talked about the lacrimal canal. When we talked about the eyes, we talked about the lacrimal canal again, because we have these this lacrimal gland that produces tears. And tears are constantly being produced and moistening your eye, right? And then the tears drain into this nasolacrimal duct, which moves down into the nasal cavity and then drains down the nasopharynx and into our through our esophagus, right? So this actually moistens the air that's moving into the nasal cavity. So this is important for us to be able to moisten that air, because we want moist, warm air moving into our lungs. We don't want cold, dry air, because that would be more damaging, okay? Oh, what did I do? There we go. So as a result of having all of that, all of those tears move into our nasal cavity, this increases the chances of a runny nose. So a runny nose is a rhinorrhea. It occurs when you have a cold, when you have allergies, and it also increases if you're crying, because think about it, when you're crying, you're producing more lacrimal secretions. So more secretions are going to move into the lacrimal duct. Yes, they're coming out of your eyes as well, but they're going to go into that nasal cavity, which is going to cause you to have that stuffy, runny nose that is associated with crying. And in the winter, when you are outside and it's really cold, your nasal cavity, so that water, that fluid is still moving into that nasal cavity, but now all of that moistness isn't moving anywhere. So typically that solution moves around, helps to moisten the air, but it goes down the throat. when it's super cold out, the cilia can't move that solution around as effectively, and so it comes out as a runny nose, which is why in the middle of winter, when you're standing outside for a long period, you get a runny nose. Fun little information there, right? So now we can, you know what, it's been 15 minutes, so I will stop here and we'll get into the pharynx in the next video. Have a great day. Bye.